What's up, iOS developers? This is Sheldon. Welcome back to iOS tutorials by Sheldon. Today we're gonna make another video about iOS development. Today actually I won't do any actual coding, and we're gonna focus on the new language features for Swift 4.1. Actually, at the time I recorded this video, Swift 4 was just released like a few days back, early this week, and along of course with the newest is Xcode version 9.3. So if you want to use this Swift 4.1, you gotta download the latest Xcode 9.3 from App Store or from the developer portal. As you guys can see in the screen, I'm actually found a very well organized blog written by Paul Hudson. So shout out to Paul Hudson that he's writing such good blog. But I think his blog is just a little bit too concise. So if you are a beginner or intermediate iOS developer, you might not be able to fully understand whatever he's writing in this article in Hack with Swift, of course. So I'm gonna give you guys a very detailed or every information that you need to understand what's new in Swift 4.1. By the way, he also included a repository in the GitHub, so if you guys like it, feel free to give him a star in his GitHub repository. I will attach all the links of this blog as well as the repository in the video description. One thing to mention that if you download your Xcode prior to Xcode 9.3 and you have already created your project before this, of course, the default Swift language won't be Swift 4.1. So to change your whole project's language into Swift 4.1, you just need to select your project file or the workspace file. You find your target, you go to your build settings tab, and you just need to search Swift language, and you can easily choose your Swift version to whatever you needed. Okay, with that being said, let's jump into the blog. So the first feature he summarized is called synthesized, equatable, or hashable. So first we got to understand like what is equatable and what is hashable. Actually, equatable and hashable are two very useful protocols that built in iOS. Basically, if you make your class conform to equatable, you will able to compare your instance that is created from the current class and check if they are equal. So the example he's giving here, he created a struct called person, and he's making the person conforming to the equatable. If we switch to the playground, I can explain a little bit better to you guys, I think. Prior to Swift 4.1, we have to implement this function. But because of we have Swift 4.1 support for my playground, even if I commented this function out, we're still able to run it. Otherwise, the compiler would cry for it. Yeah, so in this case, you guys can see I have created two persons, person one with first name, last name, same, age, same, but cities are different. So in Swift.1, although we don't need to write any function for equal, but actually by default, it will compare each and every single property that we have for this current class, which means it will make sure first name, last name, age, and city are both same at the same time. Otherwise, these two persons will be different. But in a lot of use cases, actually in our project, this is not true. Actually, we only need, for example, the first name and the last name to be able to identify these two persons are same. If we override this existing function, of course, this person would be true because we only care about the first and last name, and if that's the case, this person should be same. Another thing related to equatable is called comparable. If you are interested, basically comparable, in that case you have to override greater than or equal to be able to compare them. That's why it's called comparable. And another thing he mentioned here is hashable. So hashable is actually used if you're familiar with the idea of the hash table or hash map. In iOS, it's actually NS dictionary or just dictionary as well as set. They are hashable. Basically, if you have a hashable object, means you can use its hash value to find it. To search a hashable object in dictionary or set, the computational time will be O of 1. Thing is, to create a hashable, you have to have a hash value. We used to create a hash value. I mean, he gave an example, use the first name dot hash value and with some combination with the last name dot hash value and some random number to create a unique hash value. So in this case, the hash value will be kind of hard to duplicate. And in Swift.1, you don't even need to write this hash value because it will try to generate a pretty good or decent hash value automatically for you. I mean, definitely Hashball is much more useful to me than Equatable because, as I said, Equatable might require everything to be equal if you use the default operation, but it may works for you. Moving to second feature, which is called key decoding strategy for Codeball. Codeball is also a protocol that was just introduced in Swift 4. The most use case for Codeball is parsing JSON data into our array object. I have made a tutorial of how to use Codeball to easily parse JSON data into table view, so feel free to check that tutorial. And we do have a little bit improvement in Swift 4.1. Basically, that will be our flow, right? After downloading callback, you're gonna have the JSON data, which is just downloaded from NSURL session or whatever LMO file or third-party SDKs. Usually, they will give you a JSON data that you can use, okay? So using that JSON data, we can simply create a decoder called JSON decoder, and we just use this decoder.decode from JSON data into our Mac class that he created. This will be an array of Mac, of course. And the new option here in Swift.1 is actually called key decoding strategy, and now you can use .convert from snake case. So usually we use camel case as a key of our JSON dictionary, but in some cases we're gonna have snake case, which is something underscore something underscore something, and we can easily parse those data into object now as well. So of course that's the decoder part of Codeball, and also you can use encoder part of that Codeball as well. You just need to create a JSON encoder, and you can easily encode your object into a JSON data. Here it's going to be called encoded. Okay, so moving on to the third feature that he summarized, conditional conformance. This might be confusing if you haven't seen actually the syntax here. Okay, so starting from the beginning, for example, if you create your custom protocol called purchasable, and you're gonna have a function that called func by. Basically, every struct that you made, for example, book that confirms to the purchasable, will have to implement a function that is required here. So you have to write a function called func by, otherwise your compiler will cry and you will be not able to build. And actually now we are able to write a extension conditional conformance, right? So now we're actually writing an extension of array. And actually if you are making an array that conforms to the purchasable, and you are making sure each element of your array also conform to the purchasable, in that case you can write a function called by. This line by is actually belonging to this array, and for each item here, which is item in this array, which is pointing this element, and it will also have a by function. So in this case, if you create an array of purchasable, you are making sure array also will be able to have this function called by, and when you call that thing dot by, every item will be calling dot by, automatically. So this is what we call conditional conformance. So next part he summarized is called recursive constraints on associated types. What he tries to say is that if you have a protocol called employee, we used to not able to create a associated type within this protocol. So basically what does associated type means? It's just like a name alias that you create an associated type, which is making sure your manager is also an employee, right? And so in that case, you're creating a new type that is also employee, and then you create your property called manager. Yeah, we used to not have the freedom in protocol, but now we have it. The example he's given is if you create a class called board member that confirm to employee, it will be having a manager. And if you create another class called senior developer, which is also an employee, it might be having a manager as well. The manager type may be the board member. If you create another class called junior developer, his manager or her manager might be a senior developer. So something like this, and you just have a freedom to make the type or to make your code organized a little bit better. It depends on you. I mean, obviously it's not that necessary. Okay, so moving on to next feature is called build configuration import testing. I think this is quite interesting because usually if you create a framework that can be used for multiple platforms, he's trying to indicate that usually we have to check OS. For example, if it's Linux, if it's macOS, iOS, tvOS, watchOS, we might be importing different frameworks. But now we actually have one more function called can import to simply import it. So in that case, we don't need to check the OS anymore. I think this is a big improvement and can make our code look much better. By the way, as you guys can see, it uses pound if and pound else. Basically, this is an indication of using macro. So this function will be also part of the macro. And actually you can define your own macro as well. Moving to the next item is called target environment testing. We're able to identify if it's a simulator or it's a real device. I think this is really helpful. In a lot of cases, we are limiting our logic. If it's a simulator, we do something. If it's a full device, we do something. Especially sometimes we might want to limit our code to print logs. If it's simulator, we want to print logs. If it's not, we don't want to print logs. So this could be useful. I mean, the example he gave is actually the use case of photos. Right? So sometime when we test our app in the simulator, we know there is no camera, we cannot take photo shoot there, so he just include a logic to grab an image from photo library, and if a real device, we're gonna call the image picker to show the camera to take images. Moving to the last but not least item, which is FlatMap is now partly CompactMap. I have written a blog about this replacement FlatMap into CompactMap, so feel free to read that. The example is given here. If you have an array that has 1, 2, and fish, and next line if you have an array that CompactMap with int of 0 is gonna be 1, 2. If you don't have CompactMap, if you just map it, it will be an optional array. But because we know CompactMap or FlatMap can filter nil, so the type of the number will be a solid array of strings if you use CompactMap here, and it will filter the fish out. Again, this blog was written by Paul Hudson, so feel free to check his blog as well as his repository. Shout out to him again for writing this good article. And I think you guys should keep posted with the latest release from Apple, and of course I will share everything to you guys, so please subscribe and stay tuned for more useful video tutorials, and I will see you guys next time.